Can you all hear me at the back? Yeah? Good, okay. So, we're going to talk today about a subject that's dear to my heart. Are your mobile users well connected? Does anybody recognize this logo? No? Okay, so hopefully this will enlighten you as to what that logo is. My name is Mandy Waite. I am a developer advocate for the Google Cloud Platform. How many of you have heard of the Google Cloud Platform? How many of you are using the Google Cloud Platform? Okay, right, thank you. You can get me at +MandyWaite on Google+, or at TechGirl on Twitter. So, really easy to remember my Twitter handle. So, straight in, the agenda is going to be like this. We're going to just kind of set the scene initially about why we really need to go mobile. How many of you are doing mobile development today? And how many of you have backends that your mobile applications talk to? Okay, not so many of you. Okay. Okay. So then we're going to look at why this is the case, why people are doing mobile development but are still kind of finding it difficult to make the move to add in backends services to their applications. Then we're going to look at something called Firebase, and that was the logo we saw before. This is the Firebase logo, and we're going to have a deep dive into what Firebase is. And we're going to talk about how Firebase can help you with your mobile applications. We'll have a quick intro, we'll look at some coding, we'll look at authentication, and we'll look at offline, how Firebase works offline. Then we'll look at what's the future for Firebase, particularly now that Firebase have joined the Google team, are now part of the Google Cloud Platform. And we have a lot of time, so I'm going to go very slowly. And as Alfredo knows, this isn't very normal for me to go slowly, so I can go slowly today, no rushing. And I will be drinking lots of water. There are Firebase stickers down here, if you want a Firebase sticker. They are quite big, but it would be very easy to take some scissors off and just cut the logo off. So you could do that if you wanted to. So come and get a Firebase sticker when you're ready. So let's talk about the mobile market. This is kind of a bit markety, but we need to kind of position this before we start talking about what Firebase actually has to offer. Apparently, 2 billion people have mobile devices, and by the end of 2020, somebody has calculated exactly that 80% of adults will all have a smartphone. And the reference is here. So if you go to that reference, that's where this particular statistic comes from. I don't trust statistics generally, but I guess this is the way we're going. Everybody will have a smartphone. Everybody will have some kind of smart device, wearables, that kind of thing. Mobile application development is enriched by the cloud because mobile applications shouldn't just run on a device and be limited and restricted to the device. We need applications to be able to talk to other users of the application, wherever that application is running. Interaction, social interaction, the ability to do gaming, interactive gaming, sharing leaderboards, to do e-commerce, in-app payments, are all empowered by the cloud when it comes to mobile. Effectively, we have on our Google Cloud Platform, we have seen that 50% of the usage of the Google Cloud Platform is towards powering mobile applications. Now, we have some very, very big users of Google Cloud Platform that do mobile specifically, companies like Snapchat. There's also new business models evolving because of the ubiquitous nature of mobile devices, and also because of things like the Internet of Things, sensors, that kind of thing. So mobile is extremely important, but you guys probably already know that. So I apologize for this slide, but I just feel like I needed to throw it in there. Google has lots to offer when it comes to mobile. We're going to be talking only about one of those things, and it's not on this list, which is Firebase. We have Google Cloud Messaging, which is extremely important when it comes to sharing messages, sharing information between multiple users of an application. We have many, many public mobile APIs. We have Android everywhere. It's on TVs, it's on cars, it's in wearables, it's on phones. When it comes to Cloud Platform itself, we have Compute, we have App Engine for running platform as a service, building applications in the cloud and just deploying them, not having to worry about building infrastructure. Then we have Compute Engine for virtual machines, build it yourself kind of stacks. and also Container Engine now, which effectively runs Docker containers in the cloud. On the storage side, we've got things covered as well. So we have a NoSQL data store, we have Cloud SQL for RDBMS, and we have this thing called BigQuery, which allows you to run analytics across very large data sets in very, very short amount of time. Then we have this thing called Cloud Endpoints, which we'll touch on shortly. And we also have this thing called Identity Toolkit. And I'm not going to talk about Identity Toolkit currently in this talk, but maybe I should do at some point in the future. So this effectively allows you to do authentication from other authentication providers other than Google. When it comes to the business side of things, we've also got you covered. We have things like AdMob for advertising on mobile, Google Play Services for building applications on mobile devices, and we also have Google Analytics for providing analytics on how users interact with your application. And the Google Cloud Platform is this. And we're running out of space on this graph because we've just added a new logo, which is this one here. So if you've seen this before, it's getting bigger. I'm not going to cover that today. We're not going to talk about that. We're going to talk specifically about Firebase. So what's up with building backends? Why are people generally averse to building backends, having to write server-side code? You really want to focus on developing your application, not worrying about backends, right? So this is one way you could build a backend now using Google Cloud Platform. It's fairly simple, but still relatively complicated. Now this kind of simplifies things everywhere. But again, there's still quite a lot of work to do in order to get up and running. We have a client device, we have a server. The server is this thing called App Engine that I've mentioned already. App Engine is running your mobile backend software that you developed yourself. It's storing data into this NoSQL data store. And we've exposed its functionality as API endpoints via this thing called Cloud Endpoints. This effectively allows the device to send data, retrieve data from the application running on the cloud. This is a mobile backend as a service. At the bottom there, we have push notifications. So this gives us the ability to say, or to register an interest in data that's being stored in the application and be notified when that data changes or gets updated, or when some new data that we subscribe to enters the system. And we can do these push notifications using Google Cloud Messaging or maybe Apple APNS. And that closes the loop. Effectively, a client device talks one way to the backend service, and the backend service sends messages back to the client. But again, you still have to write this component here, the mobile backend, and you have to manage data in the data store. So some of the challenges of mobile, this is only some of them. It's not that complicated, it's not that difficult, but there are some serious challenges that you have to overcome. And the first is support for multiple platforms. You want to support with your application Android, you want to support iOS, you want to support Windows Phone, you want to support BlackBerry, maybe. You want to support web applications, you want to support all types of different clients. Users nowadays are also quite demanding in their expectations of an application. They don't want to have to press a button to be able to retrieve new messages. They want these messages pushed out to them automatically. And a good example of this is a chat application. A chat application where you're chatting with your friends and new messages from your friends automatically appear in the application. You don't want the user to have to do something to actually make that happen. So updates are effectively happening in real time. And that's a requirement of most applications being developed today. And one thing we haven't mentioned is that these devices disconnect and reconnect to the network all the time. Anybody using the Wi-Fi network today, which is pretty good for most event standards, will find that the device comes and goes off of the network. And also situations where you're completely out of range. You may be on an airplane. The device will not be connected at all, but you still want to be able to use the application. You want your users to be able to physically interact with the application as normal. They won't see all of the latest state, but the application will work effectively. Maybe not a chat app, that probably won't work as well. But this effectively means that we have state for our application distributed across a large number of devices and in the server itself. And that state reflects the entire state of the database. So we have to handle that, which is quite complicated. We also have to scale, we hopefully have to scale to meet a large number of devices, a large number of deployments of our application. And we all want to be successful. We all want to be the next Snapchat. So when we develop an application for a phone, we expect it to be successful, right? So we need to be able to handle scale automatically and not have to worry about adding it on afterwards. And if you build a backend incorrectly, it may well be that your backend won't scale to meet that success. So these are the first challenges. And that sounds kind of scary. And that's one of the reasons why people are generally deterred from developing mobile backends. But what we're going to be talking about today, Firebase, we feel Firebase can help address those challenges we've looked at and help generally make it easy to develop applications that use the cloud without actually having to write any server-side code at all. Okay, that sounds promising, right? No server-side code, just mobile, nothing else. Maybe some rules and definitions. So, hello. So Firebase is a real-time application platform. It effectively provides all of the common infrastructure that you need in order to store and save data from client devices. And that could be mobile clients or web clients. The focus of this talk is more about mobile, and Firebase is more, its sweet spot is more mobile than it is web-based. And Firebase consists of 3 components, 2 of which we're going to talk about. One of them we're going to mention on this slide, but not talk about again. But the third one is also quite interesting as well. So the first thing is this real-time database. This effectively allows us to store and share data from client-side code we've written on the client side. That's all we have to do. It also makes it very easy to add logins to our application as well. And you know how hard that can be. You often have to work with different authentication providers. You want people to be able to log in using Google, using Twitter, using Facebook. You maybe want to integrate with your own custom authentication services. And finally, there's hosting. And hosting, as I say, this is the thing we're only going to mention once on this slide now, and not talk about it in any more detail. But this effectively allows you to deploy static websites that can support custom domain names, SSL, also features CDN, and effectively a static website with Firebase can be deployed with a single command line, or even a single click of the button. So it's very, very simple and very easy to get up and running with static websites using Firebase. But we're not going to talk about that today. So Firebase by the numbers, and we had a session at an event called Google Cloud Platform Live in San Francisco about 3 weeks ago, November the 4th. And the guys from Firebase were giving their first talk since they've joined the Google team. And one of the things they mentioned was that they now have 117,000 active developers and probably a few 100,000 active applications. And back in July as well, they blogged that they, for the first time, seen 1 million concurrent connections to their data store, to Firebase itself. And they have a console they can look at, and they can see how many are connected. That's probably risen quite steeply already, but 1 million simultaneous connections. So this thing can scale already. And this is another markety slide, but you probably want some assurance that you're not going to be alone when you look at Firebase. If you try to use Firebase, if you decide to look at Firebase, you can take some comfort in the fact that companies like CBS, Citrix, TED, Nest, Twitch, they're all using Firebase today. So let's talk about the shift in processing power, one of the key reasons why Firebase is possible, and what some of the secret stuff underneath the hood is of Firebase. Now, back in the old days, before I was born, back in the old days, we used to have mainframes. And mainframes had terminals, and terminals were connected to the mainframe via a RS-232 cable, sometimes a very long RS-232 cable. And this would be a dumb terminal. They actually used to call them dumb terminals. They did no processing at all. They basically displayed what was being thrown out by the mainframe. You had time-sharing sessions, and everything was very simple. All of the work was done on the mainframe. And then we had the PC. The PC came to power. Everybody started to get PCs. And then the rise of the server-client model, where we were able to say we do some work on the server, but we can also push much of the work off to the client as well. So things like validation, calculations, rendering, and all that could be done on the client. And all we really had to do with the client-server interconnect was to share data. And then we went back to a situation where we started to see thin clients arise, things like Citrix. Now, I used to work for Sun Microsystems, and we had this thing called Sunray. And Sunray was just basically like a video card with a screen that was connected to a back end that would display data. And then we also saw the advent of mobile devices, not very powerful mobile devices, Nokia 6310s, that kind of thing, that couldn't really do any work, but could display stuff. And so we started moving back towards having this mainframe type model where all of the work was on the server and stuff was being displayed on the client device. But now we're back in a situation where the client device is extremely powerful. And just 2 days before I first gave this talk at Devox, a guy called Jeff Atwood, on his blog, codinghorror.com, wrote this article called The Tablet Turning Point. And here he compared various different Apple devices, from the iPhone 1 through to the iPad Air 2, against his desktop. And he's found, effectively, that the desktop and the iPad Air 2 are almost as powerful as each other. I think one was 180 milliseconds and the other one was 220 milliseconds. So basically what he's found is that these devices have caught up to desktops. They are extremely powerful. So now we can start doing work on these again. And also storage as well. So storage hasn't increased exponentially in the way processing power has, because we're streaming a lot now. We don't store so much data on the phone or on our device. And also compression algorithms have improved such that we don't need so much space. But we still have plenty of space on here to store stuff. And that gives rise to this situation here, where we have a smart client running Firebase, which is a client library, but more than a client library. It does stuff on the client side. And effectively, this little Firebase logo shows that we're actually running a large component of Firebase, an actual Firebase itself, on the client device. And we're going to get into that in more detail now in the next few slides. So what happens, we have a smart client and we have Firebase, this thing in the cloud where we can store and share data. And the first thing that happens is the client library, once the application fires up, as the application fires up, it uses the client library to establish a persistent connection to Firebase. And that looks like that. The smart client would have its own local copy of data that it's interested in. This may be a case where the client has been offline for some time and somebody has been using the application and data has been stored locally. At the point where a connection is made back to Firebase, then that data can be synchronized with the actual Firebase itself. So effectively we have a local copy run on the smart client and we have Firebase itself. Once the connection is made, the local data, any changes that are made locally, can be synced to Firebase, and any changes that have happened on Firebase to data that the client is interested in can be synced back to the client. And at that point, we have Firebase synchronized on both sides. We have Firebase, the server, and we have Firebase, the client, having the same snapshot of the data. Now, that's already extremely powerful, this ability to store data on the client side. Effectively, what happens is once you use the application, you store data. It could be any kind of application that stores data into Firebase. That is stored locally, and all of the event handlers are fired at that time. So the application responds as if the data has been sent to Firebase already. It's been sent to a local copy. At some point, that local copy will synchronize with Firebase. It may be immediate if they're already connected, but if it's not connected, it may happen again after a certain point of time. So what that allows us to do is effectively provide updates from a smart client once it's connected, and then fire off updates to other clients' devices that are interested in that data. So we can effectively subscribe to data and wait for updates to it. Firebase will push those updates out to us, and we will see them in real time. Once we receive an update, new data, we will synchronize that with our own local storage to make sure we have exactly the same as what Firebase has itself. And so we always have this situation where we're trying to sync state with the Firebase, and that looks like that. And also we support multiple client devices. So we have iOS, we have Windows, we have JavaScript, we have support for Node.js, we have various support, which I'll show you in a slide coming up after the coding bit. So the Firebase real-time database, getting into more detail on it, it's NoSQL, it's JSON. So anybody who's used a NoSQL data store before will be familiar with what Firebase does. I don't know the specific details of what it is running. It probably is proprietary, completely proprietary, but I don't know the full details. So we're effectively storing JSON objects, a tree of JSON data which we can traverse. And we'll look at how that works in the code shortly. When updates arrive at Firebase, those updates are pushed out to other interested subscribers, other clients, in real time, effectively, in milliseconds, providing that device is connected. There's a very simple declarative security model that you can use to control access to the data and also to provide validation. So you can validate that the data is good before you store it. Obviously, this should not replace client-side validation. You should still be validating on the client side. But it does provide that extra layer of validation. And also, very usefully, each piece of data is mapped to a URL. So it's effectively a RESTful resource that you can access in a browser. And we have this thing called the Firebase debugger, which we'll look at shortly. In terms of user management and authentication, it's the ability to add logins to your applications. Firebase has support for email and password. This effectively allows you to manage your own users within Firebase. This will do things like password management, the ability to reset passwords via email, to add users, to delete users, to change their passwords, that kind of thing. It's very easy to set up. It's already available to you today if you start using Firebase. But you can also integrate with the common OAuth providers, such as Google, Facebook, Twitter, and GitHub. And we have a demo of, not a demo, we have a walkthrough of GitHub coming up shortly. But if you have your own SSO, or your own LDAP servers, or your own Active Directory servers, then you can also use custom auth tokens as well. So we have you covered for pretty much all of the authentication mechanisms. So coding is simple. So this is all client-side coding, remember. There is no back-end code required. The rules we talked about, the security rules, are declarative. You have to write JSON on the server side to make that work, but you don't have to write any code. So this code is all run on the client. I'm using Android as an example. How many of you code in Java here? Okay, not so many. So how many of you are developers? Right, okay. I should do a poll on which languages you're using. It could be interesting. So this is a Java example. I chose Java because of DevOps, but I did also understand that Codemotion was also traditionally a Java event. That it's expanded much bigger than Java originally. So that's why I chose Java. But we'll show some example JavaScript code soon, because Java is quite verbose. And fitting Java code onto a screen is quite difficult. And fitting JavaScript code onto a screen is quite easy. So often I fall back to JavaScript because it's much easier. So the first thing you're going to do is create a Firebase. And this is a Firebase that references your Firebase in the cloud. And here we have a common URL, firebaseio.com, plus the name of your Firebase. So you create the Firebase and you can reference it this way. That's all you need to do to create a reference to your Firebase. Now my understanding is that this doesn't open up a persistent connection to Firebase. This only sets it up ready to when you start sharing or storing or, use the right word, saving or retrieving data. So saving data looks something like this. I should really look at my slides here rather than up there. So the reference, we call this a reference up here because it is effectively a reference to the root of our JSON tree. So this is the top level of our JSON object. We can reference children of that object very simply. So we just call .child on the reference and pass in the name of the child we want to reference. In this case, record 1. That would be an immediate child of the reference we're at currently. And we can call setValue, hello Codemotion. And that's all we need to do to store some data. That's really it. All we have to do to store data. Okay, at that point you're almost done, right? You need to get the data back though. So let's talk about that next. Oh, I'm going to change slides. Ah, right, okay. So just summarizing the save options, we've looked at setValue. SetValue will effectively write or replace data at a given reference. So you call it on the reference and it will replace or add the data at that reference point. An example there is messages/users/username. Update children effectively, well, so let me give you some background on what setValue does. SetValue effectively replaces everything on that branch of the tree. So if you do a set, effectively you have to update everything on that part of the tree. It will replace everything. So you have to be careful how you use setValue. Update children allows you to incrementally update some of the keys at a specific reference point without replacing everything else. Now, there's also some rules about how to use update, particularly when it comes to child nodes. But basically, that's how you will do updates. And there's also this notion of push, which will create lists of data within Firebase. This effectively allows us to do concurrent access, have multiple clients write into a reference and adding data to it. It creates effectively a unique and chronological ID that all of the data that you're storing is stored underneath. And we have an example of that coming up. So there's an example there. Messages/users, unique user ID, which is generated by Firebase, and then maybe a username or some other reference, whatever you're storing there. When it comes to retrieving data, well, that's done by a callback or a handler, or a listener, listener-handler pair. In Java, effectively, we create the reference again, as before. We call ref.child with the record name, the actual child, the child name, in this case, record 1. And we add a value listener to it. And the value listener implements a method on data change. And when we first add the listener, this will be called immediately. So we will get the data back. And that will be the value snapshot that's passed in to the onDataChange method. So this effectively is a snapshot of the data at that reference point at that given time. Okay? So then we can do things with it. We can call snapshot.getValue and print it out, and that will print the value that we said earlier up in this line here. Hello, Codemotion. What that also will do is register for ongoing updates to that reference. So if future updates to that reference are made, this callback will also be, this listener's handler will also be fired. I can't help but use the term callback all the time. So we now effectively subscribe to changes on this reference. Whenever anything changes from a different client, on this reference, we will be notified of those changes. And I haven't really made a good slide for this yet. I just added this today, effectively, to summarize the options. You can add your listener or your callback. We have an example of what that looks like in JavaScript coming up. And as we see, we'll get the data back immediately in this snapshot object that we can look at straight away. We will then get future updates to that data. We can look for value changed events. So the value of that particular reference has changed. Child added events, so we've added some child at that reference point. We've changed the child at that reference point, or we've removed a child. So they're the 4 events that you can look for on a given reference. And you also have the option to use it only once as well. So you can just say, there's a special call when you call in the add listener that says effectively only do this once and give me the data back straight away and then remove the listener from the reference point. So if you want to retrieve the data and never ever show any kind of interest in it again, that's the way you would do it. The other way to retrieve data is through queries. And the queries they have are queries on keys, names, priorities. And they can be limited to subsets of results. And this is referenceable as well. So you can register an interest in a reference that's effectively a query. And whenever the results of that query get updated, you will be notified. So they're the ways of retrieving data within Firebase. It also supports arrays. It's a little bit more complicated the way it supports arrays. And the documentation is quite interesting on that. The JavaScript version of what we saw, what we just walked through, is this. And it looks extremely similar, right? It's idiomatic. It looks like JavaScript, but it's also pretty much the same as what we did with Java. We register a reference on our Firebase. We can call set on the reference to set the value. Here we've actually said we want to look at this record directly in the reference. So we've actually gone to record 01 straight away. And so when we call ref here, we don't have to call child record 1 to get access to it. So we're just setting the value on that record directly. And then to register a callback to get the values when they change, we just do this, ref.on, value, and provide a function, which is the callback function. And this will be called back with a snapshot of the value of the data at that particular point in time. And we can do stuff with it. We can display it, or we can update the user interface. This can also be called once. So you can change this to be once, and that's the once option that we talked about just on the previous slide. And just as an example that we don't have to just set strings, we can also set JSON objects. So we can have a large, complicated JSON object at this point and set it onto our object tree. And concurrency. So this question has come up both times I've given this talk about how Firebase handles concurrency. And of course, that's going to be interesting to anybody who's looking at using Firebase. For me, just to stand up and say, well, it works, isn't probably good enough. And so there's three main ways concurrency is handled. For writes to the same reference for multiple clients, then the last write will win. So always will be the case that the last write will win. So if 3 clients all came together and tried to write to the same reference simultaneously, the last write that was active will win. And that's obviously chronological, sequential. It depends which one arrives first, so it's quite undeterministic. But you can guarantee that one will win and the data will not be mangled and munged. We also have these lists that I mentioned before with the push method. And the push method generates unique and chronological IDs that effectively allows multiple clients to write to a reference at the same time. And it also supports transactions. So in Java, that's run transaction on a reference. You pass in a transaction handler, and the transaction handler defines a method that will be called immediately with the current value of that reference. And in the body of that method, you will do your processing on the data. You will make your changes. So you have the current value. You can then check the current value, do things with the current value, replace it, return the value, and that new value will be stored. That is done completely atomically. So there are 3 ways concurrency is handled within Firebase. This is an example of the transaction using JavaScript code. I tried this with Java, and it was just like this long, so it wouldn't fit. So again, we get a reference. In this case, we have some counter somewhere, messages/count, which is our reference, our count ref. We call transaction in this case, not run transaction, that's Java. In this case, we just call .transaction. And we create a function, a callback handler. That callback handler will receive the current value and then do stuff with it. In this case, it will increment the current value by 1 or set it to 1 if it was null. And so that effectively is all done atomically. That's how transactions work in Firebase. Pretty simple, right? Okay. Authentication and offline. I'm going to quickly walk through some authentication stuff. Let's look at the time. 25 minutes. Okay, good. So we've already mentioned we support GitHub, Twitter, Facebook, and what was the other one? Oh, Google. Yeah, I nearly forgot that one. We always talk about Google Plus sign-in and Google sign-in. We never talk about the others. So it's good to have them all there. A walkthrough of GitHub user authentication. This is pretty much the same for all of them. A few nuances, a few slight minor differences, but it's pretty much the same for each one. You go to GitHub and you create an application, and there's the URL to create an application. Once you've done that, you register a callback, and this is somewhere in Firebase, under your Firebase name. So this is where the callback will go. This is where GitHub will call once it's made the authentication, and pass in the user authentication details. Then in GitHub, to prompt a user to log in, we have a couple of options. Again, we create our Firebase reference, and then we call on the reference auth with OAuth pop-up. We say GitHub, or Google, or Twitter, or Facebook, and then we pass in a callback function. And the callback function will receive this auth data object. And auth data contains all of the information about the user that the authentication provider has. So things like its email address, its username, any other information that's available. You can also use OAuth 2 redirects, so browser redirects as well. So if some browsers don't allow pop-ups, mostly they allow pop-ups based on the user interaction, but sometimes you just can't get by with pop-ups, so you may have to fall back on OAuth 2 redirects. When it comes to offline capabilities, we often have this situation. I spend a lot of time in airplanes. I have to switch to flight mode. I want my application to still work. I want to still be able to use the application. As I said before, it's unrealistic to expect a chat application to work on a phone, unless you have a couple of friends maybe, and you have some kind of Wi-Fi tethering going on. But I don't think the airline companies would like that. So often you find yourself in a situation where you're disconnected. And again, my train journey in the morning, from the office, from home to the office, 80% of the time I'm disconnected from the internet. I have no connectivity. I need my applications to still work. So this is a very quick example of some of the things that Firebase offers for offline activities. This is called detecting presence. So what we're doing here is effectively allowing you to build in functionality like in a chat application where you would have a green dot next to a user's name to indicate that they're online, or some other symbol to indicate that they're online. Maybe a red dot to indicate that they're offline, or just nothing at all. And how would you do that in Firebase without writing any server-side code? So the first thing is, well, we have two components of this. We have the device side and we have the Firebase side. Remember, I said that a lot of stuff is stored on the device itself. So we have our own kind of small Firebase running on the local device. And for that, we have info/connected. This reference here is a special reference that every time the device connects will be set to true, and every time the device disconnects will be set to false. And that's on the device itself, right? So we have true for connection and false for not connected. Then we have another reference we define. Again, this is completely custom. So we call this presence plus the user ID. It could be anything. This is for our own use, and it's not used by Firebase specifically. Then we register a callback on the reference we had for this one up here, the info connected. So whenever this value changes, whenever we connect or disconnect to Firebase, this function will be called and a value will be passed in, and it will be the value here. So the first thing we do is to check, are we connected? So we do value.val equals true. If that's true, then we can execute the body of the code. And what we do here is we instruct, remember we're just connecting. Maybe we've just come from being disconnected to being connected. And we call presence ref, the reference we defined here, on disconnect, and this is an extremely powerful special function for Firebase that extracts the server side. It instructs the server side on what to do once a device disconnects. In this case, what we're doing is saying remove. So what we're saying is when we disconnect, we want you to remove this reference completely. So this reference will be gone once the device disconnects. So at the moment it's connected, which we're calling this method. Once this disconnects, that presence ref, this one here, will be removed completely. And so now we know that this device is no longer online, and this user that's using the device is no longer online. So we can effectively change the status. We push that status out to all of the other devices, and their status will change in the user interface. And we can also set, because we know we're connected at this point, we set presence ref equals true to say that at the moment, at this current time, the user is connected. But whenever this disconnect happens, this will effectively come in and remove the presence ref. Okay, so just to kind of wrap up on the coding part of things, Firebase works with all of these different application level development environments, Android, iOS 8. It also works with frameworks such as Angular, Ember. It works with JavaScript. It works with Node.js. So Node.js specifically for doing server-side stuff. If you want to run server-side stuff and manage your Firebase from the back end rather than the front end and the client side, then you can do that as well. And it also supports Java, pretty much the same as the Android mechanisms that we've shown already. And a quick demo. So this can rely on connectivity. So is the Wi-Fi working currently? It also kind of relies on the screen real estate as well, which isn't very big. So we have this, which is an application. It's written in Polymer. This isn't a mobile application, unfortunately, but it is a useful demonstration of how Firebase works. And we also have this thing called Forge. And I mentioned earlier the debugger, the Firebase debugger. And again, I'm struggling for screen real estate here. I think I'll go this way. That's not going to work. Maybe we need bigger projectors for next year. We do. Alfredo, take a note. Okay, so I can resize this a bit. It's not going to work. Okay, so the Firebase debugger is definitely not designed to be used on the screen this size. So what I want to show you is this application written in Polymer. It's running locally on my machine, so it's hosted in Node currently. And I'm going to create a card. So this is kind of like a card sharing application. And I'm going to call it Mandy. Where am I? Milan. I was in Madrid last week. So it's easy to get confused. And we click OK. And we don't get anything because we're disconnected from the Wi-Fi. Why has that happened? Bear with me a second. I'm going to restart. Don't want you. Go away. I don't want you. I'm not sure if I've got connectivity. Oh, I must have. Let's try again. Maybe it's logged me out. So it's logged me out, so I need to log back in again. How long have we got? 3:34, so 44 minutes. I've got a couple of minutes to get this done. Let's just move on with the slides so I can wrap them up, and then we'll come back to that once the login prompt appears, if it's going to appear at all. You know what? I don't think it's going to appear, which is sad. Anyway, so basically, I will tell you what the demo was going to do, and I can't get back to my slides now either, so. Joy. So the demo basically was going to show you the real-time updates. I would make an update in my application, I would add a card, and that card will be pushed out to Firebase immediately. And in the Firebase debugger, you would see the updates appear automatically. And it's quite dramatic how quickly it happens. It's quite amazing. So believe me, you would be impressed if you could see the demo. But unfortunately, you can't. And my slides are broken, so I'm going to have to go on with my slides like this. If you want to look at the original project, the Polymer project, there's a link there. So it's www.polymer-project.org, and there's a tutorial that will walk you through all of the steps to get up and running with the Polymer application. Then you have to work out how to change the static file that it's using. It's using that JSON file to provide data. How to update that to use Firebase. It's not very complicated. It's quite easy to actually change this application to use Firebase. Anybody writing it down? I think you're writing it, right? Right. So getting started with Firebase is very simple. Go to firebase.com and get signed up. There's a tutorial. There's also a hacker plan. So you don't need to actually put in your credit card details to get started. You can just go in there, sign up for the hacker plan, create your Firebase. You have 50 concurrent users. You have a limited amount of space that you can store data in, but you can definitely play with it. You have enough resources to get up and running with it and get started with it and start playing with it and building your own applications. At some point, you may need to upgrade to a newer plan, a paid plan. I mean, that's fairly straightforward as well. You can also authenticate using GitHub on firebase.com. So going forward, this is the last part of the talk. What's next? So they've just introduced richer queries. So these queries that we talked about earlier were recently introduced. So the ability to query data is now greatly enhanced. And they're going to continue to work on that because querying is an extremely important part when you're looking at a very, very complicated JSON object. Now the recommendation is generally to denormalize your JSON to make it easier, to make it work better with Firebase. There are many scenarios outlined in the documentation where that would work to your advantage. So you need to think about your data model when you're developing a Firebase application. Large nested structures. You can go to 32 levels deep in your JSON objects, but that's not very efficient. You should probably look at a much flatter model. But the queries will help you retrieve the data you want exactly. Offline support is patchy for some of the supported platforms, as they're working on making that better. Improved user management and analytics is in the pipeline as well, and integration with the Google Cloud Platform. So what that looks like is something like this. So this is the notion of triggers. So on the left-hand side, we have what we've seen before. We have a smart client, a mobile device, talking to Firebase, synchronizing with Firebase. What we can do then, declaratively, within Firebase itself, is say we want to register an interest in anything that changes on this data. So for this particular reference, if that data changes in any way, it was added, removed, updated, we want you to fire off a trigger. And a trigger is effectively a call to a webhook, a parameterized URL, which could be running, which could be some application run anywhere in the cloud. It could be on App Engine, it could be on Microsoft Azure, it could be your own hosted machine receiving updates effectively from Firebase when that data changes. So these are called triggers. And in this example here, we have triggers effectively firing off information about whenever data changes to Google App Engine. This is for reporting effectively. So whenever any data changes, App Engine will be called, a webhook, and the data will be passed in by the webhook, will be processed by App Engine, stored into BigQuery, this analytic tool that we have, and then you can then run analytics across all of the changes that have occurred into your Firebase. So it's effectively some kind of auditing or reporting tool. A trigger is done declaratively using a DSL, a JSON-based DSL. You define your trigger, you define your reference, and you define the callback, the webhook. In this case, it's a post method to that endpoint and with a body text that looks like that. Someone said hello. That also includes the actual data that's been changed and the original value of that data. So that's pretty much it. www.firebase.com. That's all of the information you need to know. Just go to www.firebase.com and you can get started there. So basically, thanks for listening, and do you have any questions? And I'm going to put this up for the feedback. So there's a nice QR code for your feedback. There's also a URL there as well. So anybody have any questions? Yes. Yeah, so again, I think this comes down to two things. One is the application developer themselves should only be registering interest in data that's actually important to that user. So we should give the user quite a large amount of power in saying what information they're interested in. This could be like they have 10,000 friends on a social media application, which is a lot of friends, which would involve a lot of data. That's probably too much, and we should probably limit the number of friends that the user can have. Again, that might be difficult, but the next thing would be to flatten the data model, as I mentioned before, because, again, this is a JSON structure. When you get data from Firebase, you're going to get everything below a certain point in the reference. If we flatten the model as well, we can actually limit the amount of data that's sent back to the client at any given time. There's no limits on what Firebase will deliver back to the client currently, I don't believe, but there are some limits in terms of size of the amount of data within a particular child. But there's no limits on the amount of data that will be returned in a particular call, I don't think at the moment. So I think most of it's on the application developer themselves to make sure that they don't allow the user to register an interest in too much data, and also on the developer of the application or managing the Firebase side of things to make sure that the data model is flat enough to make sure that too much data doesn't go back at any given time. Does that make sense? I mean, it's something I probably need to think about, but it's an interesting question. Any more questions? Hey. So you have a client library, you build the application around the client library. So the client library effectively, well, most client libraries effectively, so the question is, what is actually run on Firebase, right? What is actually run on the device itself? So the client library is a little bit different from most client libraries. Most client libraries effectively just wrap the API. They effectively allow you programmatically to access an API using the idioms of the programming language. Firebase also adds into it this own local data store, the ability to fire event handlers, that kind of thing. So that's what you get effectively on the local machine. But that's specific per application. So if you have like 5 applications all using Firebase, they all have their own version of that Firebase. So it's not like you can run Firebase as an application and have multiple client applications talking to one Firebase. Yeah, I don't know much about the Angular implementation, but it's well documented. One thing I've really got to look at. So one of the most popular things that's happening with Firebase currently is with Angular. If you look at Stack Overflow, most of the questions are about AngularJS. So it's a big subject, and I've not really looked into it at all. I've only been really working with Firebase like for 5 weeks, so the Angular side of things I've not even looked at yet. But definitely, it's very, very well documented. I know that's not a great answer, but definitely look into it. Any more questions? All right, okay, well, thank you for coming today. Thanks for spending your time with me, and enjoy the rest of the conference.